insignificant. We basically went out and bought a car, converted it, it's drive-by-wire. We put our drive PX in it, we train it. But the key thing here, what we wanted to do was not so much train it for recognizing specific items, right? We could have trained it to recognize cars and avoid them. We could have trained it to recognize lane markings and stay in those lane markings. But in this particular case, we actually did some of that. But in this particular example, what we did was we just had a single front-facing camera. When we went out, we drove the car about 3,000 miles. Not a lot, and we're not advocating that's all you need, but essentially we wanted to show with a limited amount of training, pretty incredible results we could accomplish. And what we did was we basically mapped that entire range of pixels out the front window and mapped that to the steering wheel angle. And so it learned how to take that visual input and how the car should steer. So in this case, we weren't messing around with accelerating and braking. It was just a steering example. But what I want to show you then is the results of this test. This is the car we codenamed it BB8. And there's audio, but since we're not playing through here, I'll just speak to it. But essentially, it's able to drive now where there's no lane markings. It's able to recognize different types of errors. Now, when we first took it out, it didn't know anything. It's like a teenager. It runs over the code. It hasn't been taught anything. So we drove it for 3,000 miles. And we drove it through cones. We drove it through all different kinds of situations. Now it's able to drive on country roads, even if there's no lane markings. Since it wasn't just trained to look for lane markings, it doesn't care. In this case, it's able to drive on back roads. Right? It can detect the difference between a road and shrubbery. It can sense poles or can sense other obstacles. And so it's really remarkable. Now, so obviously, to go into any kind of production, it needs a lot more miles. But here, again, it can detect where it should drive and steer as appropriate. And so this, again, was a huge breakthrough. I forget who asked the questions about end-to-end learning. But in this case, we were training it based on a limited set of inputs and mapping it to steering wheel angle. The other cool thing, again, we did a lot of training out here, right? And now this is running on the New Jersey Turnpike. And so this notion of it doesn't have to be mapped for specific roads necessarily. Now, the more you're able to map and run on certain environments, the smarter and smarter it's going to get. Other scenarios, again, we trained it at night, so it understands then the different conditions it's going to see at night in bad weather. I mean, this is the thing that's going to be kind of critical. Once you have snow on the road, there's no lane markings. So we need to train these cars how to handle these adverse conditions and understand, like you do when you're driving in snow, you're not necessarily looking for the lane markings, you're looking for the snowbank on the side, or maybe there's other markings that the cars in front of you have taken. Questions?